Hi everyone, welcome back. This is another video in our computer vision and OpenCV playlist. My name is Ofyong Basi, and in this video, you'll learn and master different techniques of blurring, such as average blurring, median blurring, Gaussian blurring, bilateral blurring. All these techniques are really relevant in the industry. And believe me, you will learn and you'll master these techniques practically and theoretically. So what are you waiting for? Let's jump into the code. But before then, if you found this useful, hit the like button, subscribe, and share. What is blurring? Blurring is the process of softening an image by reducing sharp details and smoothing out pixel variations. Blurring actually reduces noise and smooths edges, making the image look less sharp but cleaner. In blurring, every pixel is replaced with the average value of its surrounding pixels. And for the kernel, the larger the kernel, the stronger the blur. Why do we need to blur? Firstly, noise reduction. If you're working on images that involves or that has a lot of noise, perhaps in the background, the best thing to do is to actually reduce the noise. And to do that, we use blurring. Pre-processing for edge detection. So if you're working on edge detection application and maybe you're using Canny, for example, you actually have to blur before you use the Canny technique. And the next one is object detection enhancement. If you're also working on object detection, you definitely need to blur for better performance. And for privacy anonymization, if you're working on an application that has to do with sensitive information like plate numbers or human faces, you will obviously need to blur the faces or blur the sensitive characters for privacy. So types of blurring, there are four major types of blurring. The first one is the normal blur. The normal blur is used for basic noise reduction. So if you're not concerned about edges too much, then you can use the normal blur, and the normal blur is really fast. And the next one is the Gaussian blur. Gaussian blur is mostly used in canny edge detection. It actually helps to blur without losing too many details. The next one is median blur. Median blur is mostly used in salt and pepper noise. It also blurs without losing too many details. And the last one, but not the least, is the bilateral filtering. I really like this bilateral filtering because it helps to reduce noise in and offer sharp edges. Also, the bilateral filtering is mostly used in face smoothing applications like photo editing. And at the end of this playlist, you'll see an application which we'll build using bilateral filtering. That is our AI cartoonized application. So let's jump into the code. The first thing we need to do is to create a file called blurring. So say blurring.py, and we'll import our CV2, that's our library, which we're going to use. And the image we're going to use for this is this image called car. This is it. You can see the background, and this cloud looks a little bit dusty, and some part of this images which looks dirty. We'll just try and see how we can apply blurring. So what I'm going to do is to say that my image is equal to cv2.imread. The first thing is to read the image, and the image is called car.jpg, and that's it. So I'm going to say that that's my car.jpg. And what do I need to do next? The next thing I need to do is to see that the next thing I need to do is to actually visualize this image. So I'll say cv2.imshow, and what do I need to show? I'm showing my image and image. I just want us to see the image. So I'll say cv2.weight key, and the weight key will be 0. Let's visualize our image, and here is it. So this is our image. Our image has been visualized. So move straight up to the normal blurring, also known as the classic blurring. So I'll say that blur is equal to cv2 the blur, and what do we need? We need to pass the image and the kernel. So I'm going to say kernel is equal to, let me say 5, and I'm going to pass in kernel here and kernel here. So the kernel is a property which is used to blur the images. The stronger the kernel, the stronger the blur, like I said earlier on. So what we need to do is to visualize our blurred image with imshow, and here is going to be blur, and here will be blur, and let's see how it looks we'll try and compare it with the original image. So you see, this is the original image and this is the blurred image. This is how it looks. Everywhere is blurred, and you might not really see how important this is until you begin to work with real world applications. But just learn the fundamentals and basics and the underlying concept in this video, so that when you come across applications that are real world, you actually understand how it works and what works behind the scene. So the next thing we want to do is to, you can play along with this by changing the value and see how it works. If you see, if I change this value to maybe, let me say 15, and let's see how 15 will look, and you see it becomes really blurred, like you can't even see very well. So that's it. So I'll still leave it to 5, and what I need to do next is to see that our Gaussian Gaussian blur is equal to CV2 dot Gaussian blur, and the Gaussian blur accepts an image. It accepts also the kernel over here, and it also accepts zero. Sorry, it accepts another property here which is optional. The parameter here is optional. Now the parameter here is what we use for blurring as well, and the blurring here is called, the parameter here is called sigma x for standard deviation in the x direction. So that's it. So let's see what we have. Let me just change this to 3 and try to visualize it. I'll say cv2.imshow Gaussian blur, and say that Gaussian blur is here. And let's see how Gaussian blur, and this is a Gaussian blur, and this is the, for the normal blur. You see they look alike, but they are not the same. Irrespective of the fact that they look alike, they aren't the same. And let's move next to the next blurring technique which we actually have, and it's called median blur. And median blur is equal to cv2 dot median blur, and median blur accepts two parameters, the image and the kernel, just those two parameters only. It doesn't accept it as width and height just once, but this one accepts width and height. So let's see how we can visualize median blur, and say that cv2 dot median blur, and this will be median blur, and I'll say median blur. Let's visualize our median blur and see. Oops, sorry, I think I made a mistake somewhere. Median blur takes image. Median blur. Sorry, let's look at the documentation. No one is an expert to blend every day. And the Gaussian blur. Oh, yeah, it takes kernel, so we are not wrong. Oh, sorry, show. So that was a mistake. Sorry about that. So that's it. And median blur and Gaussian blur, and this is the blur, and this is our original. So you can see this is the median blur. Now I want you to take a look at this median blur. Amongst all these median blurs seems to blur the cloud here and makes it a little bit clearer. And if you could look clearly, you see it tries to like remove noise in terms of the dirt over here, and you might not really see it very well, but if you look clearly you'll see. And the last blurring we're going to talk about is the bilateral filtering, and the bilateral filtering, like I said before, is mostly used for human faces and face smoothing. So we'll say that bilateral filter is equal to cv2 dot bilateral filter, and bilateral filter takes 4 parameters. The first one, it takes an image. The next one, it takes let me say we're going to put 9 here and put sound in sound and sound is 7. So what basically happens there is that the first one is the dimension, and then the first one is the image, the second one is the dimension, the third one here is the sigma color, and the last one is the sigma space. So those are the parameters, and what we need to do is just say that cv2.imshow of bilateral, sorry about that, bilateral and bilateral. So let's visualize our bilateral, and that's it. See bilateral, see how it has tone everything, and it looks really sharp and quite different from these ones. The bilateral looks as if it hasn't been blurred, but it has been blurred, and it looks somewhat similar to the original image, but it has a little bit of blur. So if you try to change the kernel value here, we'll call it kernel size to maybe 15. 15 is too much. Let me make it 9 and see. You'll see what I mean. And it still looks a little bit nice, and we'll change it to maybe like 27 and see what we get. And bilateral is still looking sharp, but these other ones are, they've gone. You can't even see them very well. So you see the difference here. Bilateral is why bilateral is mostly used for face smoothing. So that's that. Hi everyone, I'm really excited that you've been able to complete this video of blurring and mastering blurring with different techniques. In our next video, we'll dive straight into thresholding. There are different mechanisms and techniques of thresholding, and trust me, in our next video, you're going to learn and master different techniques of thresholding and the real world cases of thresholding and how you can actually implement this in real world scenarios. So if you found this useful, hit the like button, subscribe, and share. See you in our next video.